Look at the foundation of any large organization, and you will find text. Thousands of pages of legislation, massive corporate contracts, dense underwriting guides, and strict security protocols. But written words cannot automatically route a transaction or approve a loan. To make policies function in modern enterprises, humans must manually translate them into executable software rules. This diagram shows the traditional life cycle. You read a policy document, translate it into executable code, deploy it to a server, and when the policy changes, you edit the rules. We treat this translation like a one-way street. Once the logic is written in a system like Thrules or DMN, we assume the software is the permanent artifact we have to maintain forever. Over time, that maintenance adds up. Developers step in, fixing bugs. Analysts tweak logic for edge cases. Unwritten exceptions accumulate directly inside code. This tracks what happens next: policy drift. The written policy and executable implementation slowly diverge into a widening gap. Eventually, the software rules become more accurate than the original document. The code becomes the real policy, reducing the document to mere historical context. Then the auditors arrive. When regulators ask why a decision was made, engineers check the rules. When lawyers ask what the policy says, they consult the documents. The two answers directly contradict. Maintaining consistency between these two systems is a massive drain on capital. Organizations end up protecting the wrong asset, creating deep legal and operational uncertainty. Computer science solved a very similar problem decades ago when scaling the complexity of modern software. They did it by introducing the C compiler. Here is a diagram of that mechanism. A developer writes human-readable source code on the left. It passes through the compiler in the center and comes out as binary machine code on the right. No programmer manually edits the machine code. When a bug needs fixing or a feature is added, the developer updates the source code. The compiler simply regenerates an entirely new batch of machine code to replace the old one. The output itself is entirely disposable. The source code is the only asset that actually matters. If software engineers abandoned manual editing of compiled code decades ago, why do enterprise organizations still manually edit the software that enforces their laws? The answer is cost. For a long time, translating dense human language into executable rules took so much time and specialized labor that the resulting software was too expensive to just throw away. Large language models changed the math. They dropped the cost of interpreting and translating complex policy to near zero. This diagram illustrates the Sertainly model. The written legal document is the source code. The AI acts as the compiler. And the resulting package of software rules is the disposable machine code. When a new regulation passes, the workflow recenters. You no longer ask which software rules you need to edit. You ask which source document changed, and you let the system regenerate the packages. The optimization target has moved. Instead of maintaining executable software, organizations focus on maintaining the policy itself and simply rebuilding the software on demand. Humans do not disappear from this loop. Their role simply elevates. Instead of hand-coding rules, human experts spend their time reviewing discovered use cases, generated requirements, and deployment decisions. Because every package is generated directly from the text, you get absolute provenance. Every digital decision is hard-linked to the exact sentence that created it. Watch how this traceability chain works. An automated decision traces back to the compiled logic, which traces back to the generated requirement, pointing directly to the specific highlighted passage in your written policy. Older deployed packages are not overwritten and lost. They remain available as immutable historical artifacts, permanently tied to the version-controlled source policies that created them. Provenance is never lost. The chain is unbroken, which resolves the policy drift problem and makes audits a matter of following a direct, deterministic path back to the source. By treating executable packages as disposable, organizations no longer have to maintain executable policy. They only have to maintain the policy itself. Take the original legislation, the internal underwriting guides, and the security standards. Those are the actual assets. Everything else can simply be rebuilt. Very soon, looking back at teams manually updating software rules will feel exactly like watching someone try to edit binary machine code by hand. And certainly, the executable logic is just a reflection. The source document is and always remains the only source of truth.